Hello everyone, welcome to my channel. So today we are going to do Leetcode daily challenge, reduce array size to half. So here I have just written about the algorithm, but before that it is must to read the question also. So that's why I will read the question. So here's the question. In this question we are given with an integer array where a lot of duplicates are also there, and we can choose a set of integers and remove all the occurrences of these integers in the array. So from this what comes to mind is that we are required to remove the occurrences. We need to choose one integer. Okay, now let us check next what all are written. Return the minimum size of set so that at least half of the integers are removed. So here comes the part. Like we are required to return the minimum size of the set. At least. That's not that at most you are required to, but you are at least. That is minimum half of the integers should be removed. And if more than half of the integers are removed, then also it is fine. So that's they want to convey here. So in this question, this completely says that it would be required that in the array we are required to pick up that how many occurrences are there for a particular integer, and after that we are required to do calculations on the same. That's the thing in this question which we are required. From this example also I was unable to get that what exactly it wants, and even from this example, like I was thinking that we need to reduce to half. So how we will be comparing that how much we are required to reduce? We would be just having one integer and its count, and like this only every integer and its count that we would be having. And what we are required at the end is an array whose size is now reduced to at least half, but that is just minimum. That minimum it should be removed to half, but if it is removed more than that also, or if it is removed completely also, the way in this example, then also it is fine. So that's why I was thinking that how I need to come up with approach in which I would be reducing to half or even more than that. So here's the catch was, let us first check for the constraint, then we'll check. So here the constraint is for 5, so we can't go till n square solution. It should be till n or NlogN. That's the thing. Array length is even. Okay, so they want to convey that it can be reduced to half. That's what they want to say. And each integer value, but we don't require to sum up. So this constraint somehow we don't require much. So now comes the part that how we need to think. So let me show you the board. So here you can see that here are the integers and here are its count. So total count would be 10 by 2, right? Adding up 10 and half of that would be 5. So now how we can reduce it to half? We can check that whatsoever highest count we can reduce from the array, that we will be starting. Because at the end we are just required to return the size of the array, not just the what are elements which are being left in the array, right? So we are here just concerned with the count. So that's why we'll take that what is the highest count we got till now, that was 4. So we will first remove that count from the array. That's the thing which we would be doing. And after that we'll check that is it now removed to half, and the answer is that it is not removed to half. So we'll put one more count and we'll remove that one also. So now it would be 4 plus 3, although it would be greater than 5, but still they have asked us that, as they have told us to remove at least half, not at most half. So that's why we can remove 4 plus 3 count also. And then after that the size of a array because here the thing is, I just wanted to show the question. So here the thing is that choosing 3 and 7 will make the array 55522, right, which has size 5, that is equal to half of the size of the array. Possible sets of size 2 are 3, 5, 3, 2, 5, 2. Choosing set 2, 7 is not possible as it will make the new array, this one, which has a size greater than half of the old size. So here we were required to return the minimum size of the set so that at least half of the integers of the array are removed. So basically, we are the set which we will be making, and that set consists of the single integers, means not the count of the integer but the integer itself, and how many elements we reduce it so that it becomes means the whole array size becomes half of or more than that. So more than half would be removed, then also it is fine. So here the answer comes to be 2. That is, we remove 2 integers and all occurrences of the same. So that's the thing which we are doing here. So from this, algorithm becomes that from array get the count of each element, and then from that count keep check that is array size reduced to half or not. And this is the all thing which we would be doing here. So for this particular problem, for this particular thing, from array getting the count of each element, we would be required to store the count, right? Either we will be using a vector or we will be using an unordered map. So again, this question is of hashing. We can, if we use a vector, means anyhow anything would work, but I'll be preferably using here unordered map. And the next thing, for keeping the check of the count and keeping it in the order of the highest count at the top, I will be using a priority queue. So this is the thing which we would be doing here. And now comes the part that how we are required to code this particular question. So let me show you the code. So here, unordered map, this is the thing we would be using. Basically, I've named this as counter because we are keeping the count. And why not count? Because count is also one of the function in unordered map. So not to confuse with the same, I've named it like counter only. And now here we are storing each element and its count in the counter map. And the next thing which we are doing here is we have taken the priority queue. In the C++ language, the priority queue by default is max heap. So that's why here we are not required to define comparator which will sort it into descending order. It will be by default in descending order only. So that's why I have directly used it. And here I have used this result and remove variables. So for this result, it will be returning our end result, and remove will be keeping a check that how much count has been removed. And here what I'm doing is I'm just pulling out one, not pulling out, just checking, or you can directly see that I'm just iterating over my counter unordered map. As it is a map, so everything in that is stored in pairs. So that's why I've taken pair in comma in P. And then from the counter, I'm just getting that particular element which would be there, and then pushing that particular second element, that is the count of that element, to our queue. And then after that, what I'm doing is here I'm just running a loop, and that loop is basically keeping a check that if my removed, which is earlier 0, means that is no element is being removed. So if my removed is less than array.size by 2, then at that context I will be simply add up the count which is there, because in the queue we are just keeping the count of each element, right? So whatever count would be there at the top, I will be adding that to the removed, and then I will be directly popping out that, because now it is no more required in the queue. And why it is not required? Because we have already processed it, and we now require the next element to be checked, and then after that we will be increasing the result, that is we have removed one integer and its all occurrences, and after that this whole process will repeat until we reach a state where this removed is basically greater than array.size by 2. So after that, it will exit the loop, and then at the end we will be returning the result. So this was all for this particular question. Now comes the part that what is the time complexity and the space complexity for this particular solution. So the time complexity would be NlogN. Because of the fact we are using a priority queue which will be sorting internally, so that's why it becomes NlogN. Or you can even see NlogK, where K simply refers to the number of elements which are there. You can say number of count which is being there, but still there could be a worst case scenario also when all of them are means basically equal to the size of the array itself, right? So that's why rather than taking K, we can take it N only, because in the worst case scenario it will be the same. And the space complexity here comes out to be space complexity is basically here again order of n only, means all the number of elements which are there because of this only. And this why not just k and why n, because there could be a case where each and every element is basically different. So in that scenario, what we would be having all the elements in our priority queue itself, right? So that's one. So now this was all for this particular question. If you have any doubt, you could comment that out. And if you like this explanation, so please do like, subscribe and share my channel. Thank you.